Hello, abstract algebra students. In this video, we will prove that matrix multiplication is not commutative on M2R. Here were our definitions of matrix multiplication in M2R from before, and now we are going to claim and prove that matrix multiplication is not commutative on the set M2R. Okay, so remember when proving something not commutative, we want to show that there exists A and B in the set such that A star B does not equal B star A. So we think the set here is M2R, and the operation star here is matrix multiplication. Because we're referring to matrices rather than their entries, we're going to use capital letters here. So there exists matrices capital A, capital B in the set M2R such that A times B does not equal B times A, where the times here is the matrix multiplication. So there exists matrices A and B in M2R such that capital A times capital B does not equal capital B times capital A. Now, let's see. To prove this, we need to choose A and B to be two matrices. Because we have an exist quantifier, we can choose A and B to be whatever two matrices we want. So I'm going to choose A and B to be the following two matrices. Now, fortunately, a lot of different choices work. I'm just going to choose 1, 2, 3, 4, and 5, 6, 7, 8. Now, we need to show that A times B does not equal B times A. So remember, the way that we show two expressions aren't equal is we consider the following calculations, and we calculate each of the two expressions separately. So consider the following calculations. And we'll start with A times B, which is the matrix 1, 2, 3, 4. Times the matrix 5, 6, 7, 8. Now, this is going to be a 2 by 2 matrix. And we'll figure out the first column first, again doing the matrix times vector product. So 1 times 5 is 5, plus 2 times 7 is 14. And then 3 times 5 is 15, plus 4 times 7 is 28. Now we'll put in the second column. Come over here to do the second column. 1 times 6 is 6, plus 2 times 8 is 16. 3 times 6 is 18, plus 4 times 8 is 32. Now I just add these numbers up and it looks like I've got 19, 22, 43, and 50. Now, that was A times B. Let's do B times A, which is the product the other way around. So B times A, you take the matrix 5, 6, 7, 8. And you multiply it by the matrix 1, 2, 3, 4. And the answer is going to be a 2 by 2 matrix. Now, let's figure out the first column first. So if I do 5, 6, 7, 8 times the vector 1, 3, get 5 times 1 is 5, plus 6 times 3 is 18. I get the vector 7 times, I get the number 7 times 1 is 7, plus 8 times 3 is 24. Now when I go back to do the second column, okay, I get 5 times 2 is 10, plus 6 times 4 is 24. And I get 7 times 2 is 14, plus 8 times 4 is 32. So when I add these up, I'm going to get 23, 34, 31, and 46. Now, we only need one pair of corresponding entries to be unequal, because matrix equality is defined when all pairs of corresponding entries are equal. So the negation of that is there is at least one pair of corresponding entries that is not equal. Here, even stronger, all 4 pairs of corresponding entries are not equal. 19 does not equal 23, 22 does not equal 34, 43 doesn't equal 31, and 50 doesn't equal 46. So therefore, by the definition of matrix equality, we may conclude that A times B does not equal B times A. And that ends the proof, because we did what we needed to. We chose 2 matrices A and B, and we calculated A times B and B times A separately, and we showed that A times B was not the same matrix as B times A. So that is enough to prove that matrix multiplication is not commutative on the set M2R. More to follow.